Okay, so you do not need to write these down because what I'm going to do is I am going to give you some notes that have these all written down, okay? But I wanted to show them to you first. So we are going to, both today and Tuesday, work with some more identities, and I'm going to show you how to work with them. But everything that I show you today and everything that I show you on Tuesday, you do not need to have memorized. These 3 identities will be typed on every single page of your quiz and test in the next however many days we have left. Okay, so these formulas, if we are adding or subtracting inside of a trig function, just like how we could not break apart a radical, we cannot break apart a sine, cosine, or tangent if there's addition or subtraction inside. So we need identities. So if we have u and v added or subtracted inside of sine, this is how we're going to apply it. The sine of u, the cosine of v, plus or minus the cosine of u, the sine of v. Okay, so I'm seeing a lot of like signs up here, like pluses and minuses and minuses and pluses. Do you, technically there's 6 identities up here. I've just squished them into 3, okay? Do you notice how this sign right here is flipped from this right here? Okay, so this is how we read this. If we're using addition inside, we're going to choose the subtraction when we apply the formula. If we're using subtraction inside, we're going to use the addition to apply the formula. When our sign is normal, plus, we apply plus, minus, we apply minus. Okay, so we're going to talk about that again. But instead of having you write these down and write them down incorrectly, I'm going to hand you a foldable piece of paper. Okay, I'm going to give you some instructions. You do need to find the scissors in your caddy. Work with it appropriately, right? Sorry, I was glaring at him. I just ran into you. Sorry. Yeah, okay. Okay, this is what I need you to do. Do you see how there's a line vertically? I want you to fold along that line. Now, if you can't see it, you can fold it backwards and then fold it back forwards. Okay. Once you have it folded, look up here. You're going to take your scissors and you're going to cut along those lines until the fold, so you have 3 flaps. So when you fold, you should see the 3 formulas staring at you, with some different formulas staring at you. And then by the end of today, you can either take this in your notebook or you can put it in a folder. I don't care. So you should, by the end of it, have 3 flaps. Here's the deal. Things like video games and cell phones, telephones in general, cars, all those are things weren't even invented when people were working on this map. Okay. So old Greek or French or European of some kind. Okay. Okay, when you're done with your scissors, please put them in your caddy so that they are not a distraction. Ask appropriately. Scissors. Yes, throwing scissors. Cut it out.
That's what I did.
All right, so let's talk about these formulas again now that they're sitting right in front of you. Okay. The sine formula. Okay. Notice how we have angles U and V. They're either going to be added or subtracted. If they're added inside, we're applying the formula with addition. If they're subtracted inside, we're applying the formula with subtraction. Okay. We take sine of U, cosine of V, and we add or subtract cosine of U, sine of V. So notice how our angles stay in the order UV, UV. Okay. Now, similarities with the cosine formula. We have two functions, but that's about it. Okay. With our cosine formula, notice how we have cosine U, cosine V, sine U, sine V, and in between, if we have addition inside of our cosine, we apply it with subtraction, and then vice versa. Okay. Now tangent's all sorts of crazy here. Okay. I could prove to you any of these formulas. And if we have time at the end of today, I can. But I don't know how much we really care about that. And I want to make sure we get through our example. So if we have time later, I'll show you. But for our tangent formula, okay, we have tangent of U plus or minus tangent of V. So notice how that's normal over 1 minus plus. So notice how this is flipped. So these two signs will always be different. And then tangent U, tangent V. So what we're going to do is I'm going to take you through 6 examples, 2 for each, and we're going to have a variety of examples. We're going to look at applying these in like 3 or 4 different types of situations. Okay. So we're going to start with our sine formula. Okay. So I want you to go ahead and turn the flap of the sine formula. And here's our first example already typed out for you. Okay. Now, I don't know if I've said this already, but chapter 5 is going to be a no calculator test. Weird. You didn't listen. Okay. Pi over 12. Is that something that is on our unit circle? No. However, are there 2 angles that add or subtract to pi over 12 that are on our unit circle? I need 2 angles that add or subtract to pi over 12. On our unit circle. Okay, so let's think about our unit circle. We have pi over 6, pi over 4, pi over 3. Could I take any of those and subtract them to get pi over 12? Which ones? Pi over 3 minus. Okay, this is 4 pi over 12 minus 3 pi over 12. Okay. So notice how I have subtraction inside of my sine function. So we can come up here to this formula and apply it. So we have the sine of u times the cosine of v. Since there's subtraction inside of sine, we're going to subtract in our formula the cosine of u times the sine, that was wrong, of v. Our angles stay in that same order, UV, UV. Okay. What is the sine of pi over 3? Eric, what is it? Good. Think about the cosine of pi over 4. Bajir, what's the cosine of pi over 4? Minus the cosine of pi over 3. Nicolette, what is it?
1/2.
Yes. Quick answer. I like it. And the sine of pi over 4. Kristen, what is it?
Vertical 2.
Yes. Okay. So I'm pretty flexible. You can write this as radical 6 over 4 minus radical 3 over 4, but I would suggest, nope, that's a radical 2. Okay. I would suggest writing it as one fraction, since we have common denominators. There is our one number that is the exact value of the sine of pi over 12. The exact value. Questions? Okay, in your homework, it is not going to tell you which two angles add or subtract to be that angle. So like, for example, we had pi over 12 and we had to figure out two unit circle angles that added or subtracted to pi over 12. That's going to be the same in your homework tonight. Okay, so you are going to have to be a little bit creative. Okay, on the right side of that flap, I don't know what else to call it, on the right side of the page, there is this problem up here. Now, what do you notice about the expression that I have typed out for you? What? 10 degrees, that's nice, right? Now, we do not have to evaluate 4 different numbers to do this. I want you to stare up at my screen for a moment, and I want you to look at the expression that I have typed out, and then I want you to compare it to the formula I have up there in red. What do you notice? You notice how it follows that pattern? Okay, so let's talk about this side over here. If this is sine 120 cosine 60 minus cosine 120 sine 60, it's following this pattern right here. So our angle, so first of all, it's following the sine, right? Angle U is 120. Angle V is 60. And what's the operation in between? Subtraction. So this is essentially just the sine of 60 degrees. Which is what? I heard him mumble. wasn't so bad, right? Okay, go ahead and close that flap. And I want you to stare for a moment at the cosine formula, okay? And I want you to notice the difference between the cosine and sine formula. The cosine formula, remember, whatever operation is inside cosine gets opposite when you apply the formula. And this one, it goes cosine, cosine, sine, sine, okay? So go ahead and open that page, and we're going to do the left example. Ooh, we get to simplify an expression. We haven't done this for a while. Okay. Do you notice how we have addition inside of our cosine? Okay. That means we can apply our sum formula. That's why it's called sum and difference formulas. There's a sum or difference in between. Okay. So we can apply this formula. Cosine of u times cosine of v we are adding inside of cosine. When we apply this formula, we have this upside down plus minus sign, which means we are going to switch to subtraction. Now what can we do? We can't do anything. We can't do anything with the thetas. Can we do something with those 3 pi over 2s? Okay, what is the cosine of 3 pi over 2? 0. And the sine of 3 pi over 2? Okay, so what is the cosine of theta times 0? And then we have negative sine of theta times -1. So what we just proved is that the cosine of theta plus 3 pi over 2 is the same as the sine of theta. Interesting. Yeah, anytime we are simplifying or doing an identity, I want those explanations, just like we did last week. Yeah. You're gonna remember because I'm gonna remind you. All right. Ooh, the next one, we are verifying an identity. So which side do you think we should start with? You really think that? No. Okay. Let's start with the left side, right? And these are probably my favorite identities to solve because there's only one way to do it. We have subtraction inside of cosine. The only thing that we can really do is use the cosine difference formula. Since we have the cosine of pi over 2 minus x, we can apply this formula. The cosine of pi over 2 times the cosine of x. Since it's subtraction inside, we're going to apply addition, sine of pi over 2, sine of x. Now, I know that most of you can already tell that the sine of x equals the sine of x. But when you are verifying this identity, just like we did in our last example, I need to actually see the steps of what the sine and cosine of pi over 2 are. All right. So what is the cosine of pi over 2? I think it's 0. And the sine of pi over 2 is 1. So I actually need to see this step of you evaluating those two functions before you move on to the next step. What's cosine times 0? Hey, don't be excited. That's fine. Thanks. There's still not a lot of excitement, but I'll go with it. Like, if you have to verify an identity, I mean, isn't that nice? 2 steps, 3 steps. Katie, do you have a question? No. Do you have a comment? No. You sure? Yeah. Okay. 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 Go ahead and close that flap, and I want you to stare at the tangent formula. We only have 2 more examples left. Okay, so the tangent formula has a little bit more excitement. Okay. Notice how the numerator has the same sign, but the denominator flips sign. But we still have UV and then UV. Now this time we do have, like up here, we have addition or subtraction separating our tangents. But down here, we have 1 minus or plus the 2 tangents multiplied. So let's start out with an easy example. We have another simplify the expression. All right, so we have tangent of theta plus 3 pi. Well, let's go ahead and apply this formula. So we have the tangent of our first angle plus the tangent of our second angle. That's what we're going to do in the numerator. Now our denominator is 1 minus plus. So since we have addition inside of our tangent, we're going to go ahead and apply subtraction right here. Okay. Tangent U, tangent V. So we're going to write tangent theta, tangent 3 pi. Okay, just like before, I need to see this middle step. Okay, so I guess we should say sum formula. 3 pi is coterminal to what angle? Hey, nice job. The tangent of 3 pi is going to be the same as the tangent of pi, which is? Nope. Y over x. It will be 0. Tangent of pi is 0. Are you not believing that? So here's a unit circle, right? Over here at -1, 0. When we take y divided by x, we would get 0. You sure you're okay with that? Yeah. Okay. Still tired? Okay, so now we have the tangent of 0, or the tangent of theta plus 0 over 1 minus 0, right? I liked that problem. That wasn't too bad, right? Okay, should we do one more? One more. Right small. Right small. What'd you say? There's a little bit of algebra we have to do in this one, okay? But it's gonna be totally fine. Now, this is very similar to the very first problem where I have the tangent of 255 degrees that I want the exact value for. Now, is 255 degrees a unit circle angle? No, it's not. So we need to come up with two angles that we can either add or subtract to get to 55 so that we can use the sum or difference formula. So just think really quickly about two angles from our unit circle that can add or subtract to be 255, just silently. Now brainstorm with your peers. All right. Who would like to share their idea? What's your numbers? Okay. What's another one? What was the other one? Okay. Any other ones? Nick, you got a very unique one. Okay. Any other ones? Right. You wanted to share? Okay. So, which one do you want to choose? Okay. I'll choose. Let's do the tangent of 210 plus 45. Okay, so let's apply this formula. We have the tangent of u plus the tangent of v over 1 minus tangent u tangent. Okay, tangent of 210 degrees. What is it? It's gonna be positive because it's in the it's in the third quadrant. Radical 3 over 3. And the tangent of 45 is 1. It would be like super cool if this is all all you had to do, but guess what? We can't leave the denominator. We cannot have a radical in the denominator. Not even a little bit. So we are going to have to rationalize. Anytime we have a radical in the denominator, we must multiply by its not reciprocal conjugate. But I'm sure this is exactly what you were thinking of now. Right? What? You know what? People's allergies have been bad this week, I've noticed. Okay, so now let's talk about the denominator first. The whole point of multiplying by a conjugate is so that our middle terms cancel and we just have a squared minus b squared. So what's 1 times 1? Okay, minus b squared, radical 3 over 3 times radical 3 over 3 would be radical 9 over 9, which is 1/3. Radical 3 over 3 times radical 3 over 3 is radical 9 over 9, which is 3/9, which is 1/3. Okay, now let's FOIL this up here. We have radical 3 over 3 times 1. We have radical 3 over 3 times radical 3 over 3. All right, we knew that was going to happen. 1 times 1. And 1 times radical 3 over 3. Okay, this is like the most work you're going to have to do of any problem. If you have to apply a tangent sum or difference formula for an exact value, it's just what's going to happen. All right, now let's talk about the denominator first because it's easier. What's 1 minus 1/3? Okay. And then up here we have, what is 1/3 plus 1? 4/3 plus, we have 2 radical 3 over 3s. So we can combine those together. Oh, we are so close. Okay. Now, we have fractions in a fraction, and that is not okay. So we need to simplify. And some of you can see how this is going to simplify already, but let's talk about our numerator first. Our numerator is 4 plus 2 radical 3 over 3. Okay, I just went ahead and squished our numerator together. And we're dividing by 2/3. Well, dividing by 2/3 is the same thing as multiplying by 3/2. Hey, we're not going to fractions anymore. This is so great. Now, that 2 is dividing the whole thing. So we have to take 4 divided by 2 and 2 radical 3 divided by 2. Do you think that problem is going to be the same amount of points as the first problem we did in class? No. No. Okay. Now, how many of you found it really annoying that we had all those fractions in a fraction? Okay. So I chose this of our 3 because I knew it was going to be annoying. What's the tangent of 60 degrees? Just radical 3. Okay. Now, if we would have chosen a 60-degree angle of some sort to use, like our 120 plus 135, we would have had to rationalize with radical 3, but there wouldn't have been fractions in a fraction, and we would have been able to take out a step. So my encouragement to you would be, if you're choosing angles for a tangent, sum, or difference, I would really try to find a 60-degree angle so you don't have to worry about fractions in a fraction. Okay. All right, and just like that, our time is done.